imperative for Lee that they don't drop the ball now. And at the end of a high-scoring half, and
halftime.
Guaranteed 4 points in the second half, David.
What's this half of? And what other fractions do you come across? The world doesn't always work in whole numbers. When you pour the liquid in, does it go 1 cup, 2 cups, 3 cups, 4 cups? No, of course not. When you pour it in steadily at the top, it can't arrive in whole numbers at the bottom. The cylinder must fill up continuously like this. And we can use fractions to label some of the amounts between the whole numbers of cups. One person who should know all about fractions is the next contestant in the Fractional Cocktail Championships. He's making a 1½ banana colada. This is his formula. Well, actually, his 4½ mula. First, take 1½ bananas. Cut each half into tenths. And put 9/10 in the cocktail shaker. Mix exactly ½ a liter of lime and lemon, 1/3 of a liter of blackcurrant and beetroot, and 1/4 of orange. Voila! 1/2, 1/3, and 1/4 exactly. Do you think he might have a problem here? What happens if you try to fit 1/4, 1/3, and 1/2 into a 1-liter container? Put the top on the shaker and shake. No. Shake the cocktail. Then pour out the banana colada into 3 half glasses. When you cut a cake, you want to be sure that everyone gets the same size slice. That's easy if there are only 2 of you. But what if there were 3 people? Good. But what about the round one?
That person is getting that person is getting little.
Now try for 6 people.
We could start by making half that one. Not like that, and then half that one. But then just make sure that they're adding. So you know when.
Each of these pieces is 1/6 of the cake. So, if you put 2 of them together, you'll make 1/3. 2/3. And altogether, 3/3. If you put 3 of the pieces together, you'll get 1/2. And all 6 of them together, and you'll get the whole cake. But fractions didn't add up so easily in the Arab's will. Abdul had a good life. "My time has come," he said. "It is written, 'To you, my sons, I leave my camels, which are my only possessions of value.' To Ali, the eldest, I leave 1/2 of my camels. To Farouk, 1/4. And to my youngest son, Mustafa, 1/5. For when you can handle fractions, you are ready to make your way in the world." And so the old man died. It was the will of God. But the will of Abdul turned out to be a problem, because he'd left them 19 camels. Ali agonized. "If I'm going to get half of 19, I'm going to need half a camel." Farouk was flummoxed. "I'm supposed to get 1/4, but 4 doesn't go into 19. Mustafa mused, "How in the name of the Prophet am I going to divide a camel into little pieces?" Then along came their wise old Uncle Yusa with his antique camel, Cleo. Yusa was as generous as he was wise, and he offered to help solve their problem. He even offered to add his own beloved Cleo to Abdul's herd. "We couldn't possibly accept a generous offer," they said. But he insisted, and so she joined the other 19. With 20 camels, the problem was easy. Ali saw that his half of 20 camels was 10. Then it was Farouk's turn to take 1/4 of 20. His 5 camels were delighted that they had not been divided up. 1/5 of 20 is 4, so Mustafa was able to choose the best of the rest. And wise old Yusa was left with his faithful Cleo. Why didn't the fractions add up without the extra camel? And why did Cleo make all the difference to the Arab's will? How many of these colored candies do you think you get in a package? And how could you find out what the percentage of each color is? These mathematicians started by counting the total of all colors. That was 40. Then they counted each color and divided it by 40. 6 green divided by 40, 15%.
But we divided 6 by 40.
6 purple also 15%.
For orange and pink.
4 orange and 4 pink, 10% each. 5 red, 12.5%.
12.5%.
Would you expect the same percentage for all the colors? When you add a lot of packages together, would you expect the percentage of pink ones to go up, go down, or stay about the same? And what would you find out in this pie chart? One of the hazards of shopping is that you get bombarded by all sorts of special offers. How can you check these offers to find out if they're completely honest?
Well, it's got a yellow strip at the top saying 10% extra free. They put it as though that yellow strip is actually that 10% that's extra free. If you measure from the top down to the bottom, it's 17 centimeters. And if you measure from the bottom of the yellow strip down to the bottom, it's 143 millimeters. If you compare the difference between 170 millimeters and 143 millimeters,
what do you think?
the difference
Is that
between the
10% extra?
The answer
This one says there's 440 grams instead of 400. And it's clear that the extra 40 grams is 10% more, because if you divide 400 by 10, you get 40. So that's 4 grams for 1% of 400. And multiply that by 10 being 10% makes 40. Add that on to 100%, which is 400, and you get 440.
I'm going to multiply by 20 equals 90. Then I'm going to divide it by 100 because it's 100%. Equals 9. So I add 4.5 to 9. Equals 5.4. It's right, so it's there.
Sometimes, as well as measuring, you can count the contents.
Cut it in half there and count them.
The package says 33% extra. There were 20 crackers in the old package. How many would you expect to find in the new one? These are percentage detectives. No, not Cagney and Lacey, but Julie and Elaine, officers of the Consumer Protection Service. Their job is to visit all sorts of stores to check out weights, measures, and percentages. They do their best to make sure that the consumer gets a fair deal. How much fat is there in the ground beef they bought? The maximum amount of fat in ground beef is supposed to be 25% by weight. To check it out, they divide the meat into 3 equal samples. They keep one, they give one to the store where they bought it, and the third goes to their laboratory for analysis. The scientists here can measure all kinds of contamination of water and food, so they can tell whether milk has been watered down and how much beef there is in a sausage. But you don't need all that apparatus to investigate the fat in ground beef. These mathematicians are comparing some expensive extra lean meat with a lower-priced version. Cheap meat has much more fat in it. All the white lumps are fat. To make it a fair test, they weigh out the same amount of each and cook them at the same gas setting. Once the water's boiled off, they can squeeze out the fat. This is the fat from the low-cost meat. What do you expect from the expensive meat? And how will you work out the percentage of fat in each kind of ground beef?